Hydrogen, that's 2.1, and chlorine, that is 73.2. Then they ask for the molecular formula. But to get the molecular formula, you must first find the empirical formula. Always first. Okay? So for that, you're going to do the same thing that you just did. So it's 24.7 over 12, 2.1 over 1, 73.2 over 35.5. Really, what did you get for the first one? Okay, you can't round off just yet. 2,0583, blah, 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 blah. This one is 2.1. And what did you get to me for the next one? 2,0619. Okay. Then you must divide by the smallest one. That will be the smallest one. And then you will get it to be 111. Nee? So then that means that your empirical formula is CHCl. That is your empirical formula. But the question was find the molecular formula. So what you're going to do then, you're going to find the mass of your empirical formula, which will be 12 plus 1 plus 35.5. And that gives you 1348.5. And then you say, okay, what do they give me? They say the molecular formula is 97. So you're going to say 97 divided by 48.5. So divided by the empirical formula. And you get 2. So that means the molecular formula is twice the empirical formula. So it means the molecular formula, you're going to take that thing there and say C2H2Cl2. This thing will count 1, 2, 3, 4, 5, 6, 7 marks. And remember, who sets up your question paper for September? I do. 7 marks. Good question. Did you make a note for yourself? Test question. Revise. This is the 4th time. No, not 4th. 7th time we've done a question like this. That's a lot of practice. Am I? Yes. Okay, can I go on? Then question 8, I didn't give you the memo. Question 8, you had to do 8A. They ask you how many grams. So let's say, what are they asking? What must we calculate? The mass. Then at A, they give you 200 cubic centimeters. Asina, what are they giving us there? Like what thing? They're giving us the volume. And Asina, are we working in cubic centimeters? So what are you going to do? Yes. Volume. And then they give us, see, 0.1 moles per decimeters cubed. What in the world are they giving us there? Page back, what is measured in moles per decimeters cubed? Then Atlang, which formula did you use? Read it for me. Capital MV. What does the capital M stand for, Atlang? Molar mass. You need to get that. And they say we are talking about sodium chloride. So it's 23 plus 35.5. Yes, Trust. I not Trust. Says where?
They're giving us the mole.
No. Moles per decimeters cubed. Page to page 10. What? Concentration. So you need to know your units. Otherwise you don't know where do you fit in the 0.1. If you fit in the wrong place, it's wrong. Okay, so concentration is 0.1. Mass we want to get. Molar mass is 58.5. And the volume is 0.2. And if you calculate that, Karabo, what do you get? Trust you. 1.17 and the unit? Grams. Any questions? Then you have to do for C as well. Again, they ask for the mass. They give you the volume is 500 cubic centimeters. Trust you work in cubic centimeters. What are you going to do? Then they give you 0.25 mole per decimeters cubed. Umalemo, what do they give you? And then they give you, they say of copper sulfate solution. What is this things? If we have that with the copper sulfate, what do you call it, Amora? You don't just call it copper sulfate, you call it something copper sulfate. You call it hydrated copper sulfate. Are you writing this down? Hydrated. Because there is water, and when you drink water, you are hydrated. Without water, you are dehydrated. Okay, so Carabello, what did you get for the molar mass? Yes. And then really, if you calculated the mass, what did you get? 0.19. Is he right? All right. Yes. What part? They give you that. And the linear formula is a multiple of the interval. We did this in class. Where were you? Were you present? It was that extra class. What was the homework for this weekend? No, you had homework. Study for the test and go through the videos if you missed the work. When does your book be up to date? Tomorrow. Otherwise what? And debits. And watch the videos, because this is why you can't do the homework, because you didn't look at this. And this is also in videos. I said this is the most important lesson of your chemistry career. Whose stuff are you going to borrow? Did you ask them?
No, let's go.
They must just say yes, it's their property. Okay. Then back to your notes, sorry. Okay. Let's say you have written a test in science class. Let's say the test is out of 35. Okay? Page 13. Okay, where am I with my questions? Relate to me. To me, let's say you write a test. The test out of 35. How much did you get out of 35 for the test? In your head? Where you wrote a make-believe test. In that make-believe test, how much did you get for the test? Okay, so to me is aiming for 20 out of 35. To me, you get the test back. What is the first thing you do? You check the percentage. So you want to actually get or determine what was your percentage. The fancy word is yield. What did you get at the end of the day? What was your ability on that day? Yes?
7%.
How did you get to that?
I said
100 divided by 35 times 20, or 20 divided by 35 times 100? And you said 70?
No, 57.
57. Are you fine with that? Okay, don't aim for 20. All right. Now the same thing in a science lab. You remember we did, I added this. There. All right. Now, when we do that, you saw that black flakes that formed at the bottom? That is called impurities because this thing has oxidized. Okay, so it means not all of it in here is zinc. Some of it is actually oxygen, or it was dirty because kids or me were touching it and there's oil on there and. So sometimes when we do in a science experiment, we think, according to a piece of paper and the calculations that we do, we think we must get 200 grams of product. And then we do it and we only get 75 grams of product. Then we determine what is our percentage yield, how efficient was our experiment. Are you getting me? Okay, so in grade 12, you are going to look at, all right, you'll see the science experiments aren't very efficient, like 30% efficient, and then we look at ways in which we can manipulate the reactions to get a higher yield. Yield means product. Okay, so percentage yield is percentage product. What did you get? Okay, it says there, due to human error or impurities, the yield produced in a chemical reaction is not always 100%. Like I've just said, sometimes it's a bit dirty or the experiment went a bit wrong or whatever. Then we're going to calculate the percentage yield. So first you're going to determine the theoretical yield. The theoretical yield is that which you should have formed when everything reacted, when everything was perfect. What should you have gotten? Like 100% for a test. Okay, like what is, if you got full marks for a test, everything went perfect, what should you have gotten? 100. Yes. Okay, so that theoretical yield is what you will find in your mole table. That which you will find in your mole table. Okay, so yield is what again, Lesego? What is yield? Product. That which you got, what you produced. Okay, so you're first going to determine your theoretical yield, your theoretical product, that which you should have gotten. And then the test or the question will say, you actually got 20 grams. Determine the percentage yield. Then you must first go determine the actual yield that you should, the theoretical yield. And then you do your calculation. How are you going to do the calculation? It's the actual yield, that which we will be given, over your theoretical yield that you will find in your mole table, times 100. Now this equation is not on your data sheet, which means you do not have to memorize it off by heart. Okay? You must just apply it. Okay, let's see. How will that work? It says there, calculate the percentage yield if 136 grams of steam is produced from 20 grams hydrogen and excess oxygen. All right. Asina, what are you going to do? What's the first thing you're going to do? Write an or A. Say again. What is the first thing you are going to do? Write a equation. Not a formula, equation. With the help of formulas, you write the equation. Okay, so they say steam is produced from what? From hydrogen and oxygen. So you're going to say hydrogen plus oxygen. Now, see, what in the world is steam? So, what is produced? Think hydrogen plus oxygen. What do you think can steam be? H2O, water. Water in the gas form is steam or water vapor. Atle Hang, is this balanced?
No.
What are you going to do?
You have to put the 2 in front of the H2O. And you also have to put a 2 in front of the H.
What's H's name? Yes. Okay, so now it's balanced. Yes?
For the final product, this T, why is it not hydrogen peroxide?
Because to form hydrogen peroxide, you need special conditions. If you just add hydrogen and oxygen together normally, it gives you water. Okay, so I highlight that a different color because that is just my recipe. It's not what I actually have. Okay, so that is mole. Then I have beginning, change, end. Karabu, what is something that I can immediately write down without even doing any calculations?
Oh,
0 to 0? Where does my 0 go? At my products, at the beginning is 0. So just 0. Then, I say, calculate the percentage yield if so much steam is produced. So that which they give you there, that is your actual yield. Your actual product. That does not go into your table. That does not go into your table. Okay? In here is your theoretical. Okay? Now, they say it's produced from 20 grams of hydrogen. Can I fill in 20 there? Trust. You won't know because you didn't watch the videos. Omelemu. Can I fill that 20 in there? Why not? Call a friend. Ask the audience. 50-50. Audience? Yes, let's say. It's not a mole. This is called a mole table. You have to convert it to mole first. So we're going to do that. So I'm going to look at hydrogen now. I want to calculate the mole. The mass is 20. The molar mass for hydrogen is what, Amara? Okay, so am I going to fill in a 1 there? No, obviously not, because I was... Why do you say times 2? Okay, so hydrogen is a diatomic molecule, so it's 1 times 2. But Amara, aren't you going to say times another 2? No, if you look at the molar mass, you never look at the mole ratio in front. Okay, only at the formula. So it's divided by 2, that gives you 10. So you have 10 moles of that to start with. Now, they say you have excess oxygen, meaning more than enough. They don't ask a question regarding oxygen, so I'm not going to waste my time in filling in oxygen.